At this point, we have a nice full simulation cached out for this explosion. This is working quite well. And I've also flipbooked this explosion from the camera for the wide shot. So if I pull up that camera view, then this helps to illustrate how much that custom wind force adds to the simulation. So this might be a bit hard to see with that dark smoke on the black background, but as our explosion smoke is rising up in the air, it's getting more influenced by that custom wind force, and this really makes our sim look much more natural, and we can perhaps make that a bit more visible if we crank up our brightness in the viewport, and this will of course show up much more nicely once we start doing some properly lit renders of these explosions. But enough about the simulation for now. Let's take a look at how to make these volumes look nice in the renders. So this looks kind of cool in the viewport. It doesn't look great, so we have to do a bit of work on this to yield a nicer rendered result. So taking a look at this rendered and composited shot here, one of the nice things that makes this explosion look good is this effect of light traveling through the volume. And this sort of sense of light traveling through the volume is something that many renderers can physically simulate by just tracking light rays as they scatter around and bounce around inside the actual volumes. And this can look awesome, and it's the closest thing to simulating reality, I suppose, in terms of the actual rendering process versus real life, but different renderers handle this light bouncing effect within the volumes better than others, and it does tend to lead to some very slow renders. So it's a very common effects workflow, regardless of what rendering engine you're using, to kind of fake some of this light bouncing around inside the volume here. Because really, when we have these very bright flamey areas, you would expect that to illuminate some of the surrounding voxels, and there are some ways that you could potentially go about calculating some approximations of this light bouncing effect inside these volumes, and I have seen some cool custom tools that do this sort of thing, but in recent versions of Houdini, they've provided a really awesome tool that can help us to bake in some of that light scattering effect for us before we run our renders. So if we go back to our cached out sim here, let's go to a frame where our fireball is a bit more developed. It looks like frame 114 should be a decent test frame for this. And I want to apply this light scatter baking after our simulation cache, of course, but before we do this scaling up of our sim, because I really want to be able to have full control over how much we're scaling up this simulation. So as we're working on the shot, maybe we don't want to scale this up quite as much. Maybe we want it even larger. And I don't want to have to recache any of our intermediate caches or potentially change the results of the actual light scatter baking process by changing the scale of the simulation that's going into it. So it's safer for us to do all of our light scatter calculation just based on our raw sim. And because this light scatter calculation can be a little bit slow, we're going to bake out another cache after applying those changes, and then we can reapply this transform scale just before we send that off for rendering. So to bake in this light scattering, we have this awesome tool called Pyro Bake Volume, and if we attach that to our cached out sim, you can see we have some settings on here that are pretty similar to what we saw on the Look tab for the Pyro Solver. So if we display our Pyro Bake Volume, then this doesn't look very nice just yet. This is just giving us this smoky mass here, because this isn't doing any emission based on the temperature by default. Right now we only have smoke enabled. So to turn on that flamey emission, let's go to the Scatter tab. You don't really need to worry about the fire or secondary fire tabs for this. We're going to do all our work on the Scatter tab and Smoke tab. So let's turn on this Scatter option. And it took a moment for this to calculate, But as soon as we turn on this enable scatter option, you can see this is doing some nice emission based on the temperature in our sim. If you look at the bindings tab on the Pyrobake volume, you can see which volume fields it's using to control these properties. So the smoke is just based on the density volume, and then the scattering effect is based on the temperature, and it's creating a new volume called scatter to represent that sort of scattered lighting throughout the volume. And then it's using this density volume as a mask for the scatter, which is going to help us get some more crunchy details back in the explosion, which we'll look at in a moment. So going back to the scatter tab, we can control the overall intensity of the emission based on temperature by changing the scale of our intensity here. So if we turn that up a bit to 350, it takes a moment to calculate that, but this gives us a much brighter emission there. And the brightness of our explosion fireball here is also going to be affected by the density of the smoke. So right now we have some fairly low density smoke, which isn't doing much to obscure the brightness of this emission here. But if we go back to the smoke tab and crank up this density scale a bit, then you can see that this more dense smoke is blocking out some of that emission. So you kind of have to balance your density scale versus the intensity of that emission. And you don't have to worry about getting some of these scales perfect right now, because we can tweak this further while we're rendering it, but this seems like a good starting point. Now going back to the scatter tab, there's an additional control for the hot core scale, which is essentially going to scale up the emission even more where there's a very bright scatter. And I didn't feel like this was really necessary for our explosion, so I'm not messing with that at all. This default color ramp here works pretty well for explosions in general, so I'm just going to leave that as it is. And then when we get down to this blur step, this is where things get interesting. So the way that this approximates the scattering of light throughout the volume and kind of fakes these light rays bouncing around inside this fireball here is by blurring out our temperature field. When you think about these light rays kind of bouncing and bleeding light throughout the volume, you can think of that sort of as a blur effect on that emission. So turning off this blur scatter checkbox will disable that entirely. So now you really just see these hard edges wherever we have those hot temperature fields, just harshly mixed in with our density volumes for the smoke. We're not really seeing any light bleeding happening whatsoever. So let's turn that blur scatter back on. And we have a few different ways that we can control how this blurring works here. We can just crank up the number of iterations to induce more of this light scatter blurring. This voxel radius indicates how many voxels it's going to run that smoothing operation over. So the higher this radius, the more blurred and soft that scatter field is going to be. And as the tooltip tells you, this is a number of voxels. This isn't a world space radius. And we are getting some decent results just out of this default blurring here, but you can also use additional blur steps to control this further. So we're not really seeing any difference by turning that on and leaving the number of blur steps at 1 because it's really doing the same thing. But as you increase the number of blur steps, it's going to do multiple blurring operations at different scales. So once again, if you look at the tooltip for the number of blur steps here, this gives you a bit of a hint about what exactly this is doing. So for each of these blur steps, it's going to rerun this blur operation at a larger size. So it's doubling the filter size for each step of this blurring. So this will certainly induce more soft scattering into our volume here. When I turn this up to a value of 3, you can see that more of this light scatter is kind of bleeding out into these areas that were previously just kind of straight up dense smoke down there. Now that light is just scattering into all those areas a bit more. And the last blur setting here that we haven't looked at yet is this downsampling. So by default, this is downsampling our field 2 times because when we're doing these blurring effects, we don't necessarily need all of the detail in the field that's getting blurred. So this can speed things up a bit by allowing downsampling of that field before this blurring takes place. So you can try speeding things up more by downsampling those original fields even further. Or if you're feeling like you're losing too much detail from your original temperature field versus your end scatter result, then you could try turning off downsample entirely. So I'll turn this off just to see what that looks like. And now with that downsampling turned off, this did take much longer for the pyrobake volume to process, and things have been a little bit slow the entire time I've been working on this. Of course, I edit out all of this time spent waiting for these updates, so if there is a bit of a lag between changing some settings on the pyrobake volume and seeing your results, that is normal. But in this particular case, when turning the downsampling off, this took almost 2 minutes for this to update, and that's a bit painfully slow, and I don't really see much visual improvement from doing that. With the downsampling turned off, we do get a little bit more of our original temperature field shape preserved, but it's debatable whether that's really much of an improvement or not. Because that's not a very clear benefit, I'm going to stick with the default of 2x downsampling. So that took about 10 seconds to process instead of the almost 2 minutes that we had before. So let's stick with that. And now one of the key parts of setting up this light scattering effect is maintaining some of this crunchy detail on the surface of this fireball here. If we go back to our rendered version, and I should point out that this version that's rendered and comped here isn't the same exact simulation as we're working on in the viewport here. I've run a new fresh version of the sim as I've been working through this shot. These renders are from my previous development version, but they should be quite close to each other. And as we scroll through this explosion here, you can see we have lots of these nice crunchy dark areas around the edges of the fireball, and that bit of detail is very important, and it's one of the key things to get right with an explosion. We don't want this to just turn into a big glowing orb. We really need to maintain some of these really crunchy dark details on the surface there. And the pyrobake volume handles this in a pretty clever way. It masks out that scatter effect based on where we have some very low density values. So if we turn off this enable mask, then you can see we have just this uniform, very soft and glowy look to our explosion, which actually kind of looks pretty cool just from an aesthetic standpoint, but we are really losing that crunchy detail that we need in our explosion. So let's turn that masking back on. So what this masking actually does is this creates a 0 to 1 multiplier across a density range specified by our mask center and mask width. You can use a custom ramp to design a different density range for this, but I didn't really find that to be necessary. We can just use a more basic range defined here. And because we have a density range with a width of 0.1 centered around this value of 0.2, we're actually grabbing density values from 0.15 to 0.25 and then setting an emission multiplier from 1 to 0 based on that range. And when that value is multiplied on top of the emission, effectively that's removing the emission from some areas, which brings in some of these dark, crunchy features that you see here. So of course we can play around with these values a bit, could try increasing the mask width a bit here, and that's a pretty subtle change. If we start moving this center point around, then you'll see some more significant changes in the areas that are getting masked out. So setting that mask center value to 0.1 is really masking out the emission from all of these surface areas pretty aggressively. So we're just seeing a lot of smoke and less emission here. And this is what the default value of 0.2 for the mask center looks like once again. And if we raise this mask center to a value of something like 0.5, then this is a bit less successful in masking out some of those crunchy surface areas that we want to see. And this will give us some detail in our explosion render, but that higher center value is really just kind of pushing this affected range inside that density volume a bit too much, and we really want to focus this a bit more on the surface of the explosion. In this case, it looks like a value of 0.17 for both the center and the width is working pretty well. You don't have to get this absolutely perfect in the viewport because you'll likely want to tweak this as you're rendering things. And I should also add that this shader setup that we're doing now will work quite well for a Mantra or a Karma render, but for Redshift, we're going to need to do some more customized stuff to reproduce this same behavior. We can reuse the scattering fields that are created by this pyrobake volume, but we will need to do some extra work to do some of these masking things, which you'll see later. It's also worth pointing out that when we do this masking process, this is actually not modifying our scatter data at all. This is purely a shader computation. And we can get a better look at our individual volume fields by dropping in a volume slice and connecting this to our pyrobake volume. And then on this volume slice, I'll set the source group to scatter and then display that. And if we take a closer look at the edges of this scatter visualization here, if we go back to our pyrobake volume, then nothing is changing when we turn the enable mask on or off. If this was really modifying the values of the scatter field, you would expect some changes around the edges of this visualization of those actual scatter volume values, but those aren't changing at all. This masking is purely done at the shader level, and if you're really curious, you can dive inside the pyrobake volume to investigate what's actually happening. And when you dive inside there, you'll see this pyro shader here, and you can dive inside that and then investigate some of this complicated stuff that's happening if you're really curious. And if you zoom in down here, you can see the masking setup that's used to control the scatter masking. And if you trace through the shader here, you'll see that this mask is being used as a multiplier on the overall emission based on the controls that we've set up at the top level of the tool here. And that's part of the reason that we can't just immediately render this in Redshift and maintain this same look here. We can render this right away in Mantra or Karma, and we can get a result pretty close to what we're seeing in the viewport here. And to do my final render setups, I always set up these render objects at this top object level here, but just to do some quick Mantra tests, I'm going to render this explosion geometry object directly. And when we're doing some test renders in Mantra to see how this explosion shader looks, if you want to render this with motion blur as well, you'll have to go to the Render tab, and under Sampling, turn on Velocity Blur. This will allow Mantra to use that velocity field from our explosion to calculate that motion blur. And then we can go to the out context. I'll drop in a Mantra ROP, call this explosion test. For the camera, I'm going to set the master cam for the explosion. Under objects, I'll remove candidate objects. And for the force objects, let's select our explosion geometry object here. And then for candidate lights, I'll just get rid of the star there. And now let's go to our render view, select the explosion test from our drop down here, and do a test render of our current explosion shader. So this is looking pretty cool. I'm actually quite happy with how this explosion is looking in this Mantra test render. And of course, we're focusing on rendering things in Redshift in this class, but it's totally fine if you want to do your explosions in Mantra. And if you're fine with that CPU rendering time, that's totally up to you. And in a production environment, it's not uncommon to render some elements in different rendering software than others. So perhaps an official lighting pipeline might use a renderer like Clarice or Arnold or etc., but some effects elements might be rendered directly by the effects artists out of Houdini in Mantra or Karma or whatever the renderer of choice might be. And if we go back to our scene view and select our explosion camera, we can compare this result that we see here to what we see in our render view. And flipping back and forth between them, they do look a little bit different, but this overall look holds up quite well in our Mantra render here. So as you're finessing the look of your explosion render, at this point I would focus more on the render itself and less about how it looks in the viewport. So in our network view here, let's go back to our explosion setup, and we can continue to tweak this pyrobake volume to our liking. Maybe I'll turn up that intensity a bit more and see what that looks like when we crank that up to 500. So this is looking quite cool as well. We're getting some interesting little hotspots in here. And it's also worth noting that explosions always need some extra compositing work to really look nice. We can add some, bloom and glow to some of these hotspots. And that extra bit of treatment really goes a long way toward making this explosion work well. So now that we're pretty happy with the look of our pyro shader here, let's stop this render. Go back to our scene view, and we can delete this volume slice because we don't need that anymore. And just to make our rendering a bit more efficient, we can go ahead and cache out the results from our pyrobake volume. So I'll drop in a new file cache, because this really can slow things down quite a bit if we're relying on this to calculate all of those scattering blurs and everything every time it's rendering a frame. So I'll call this new file cache explosion bake. As usual, go to our job directory and geo and explosion. I'll create a directory called explosion sim bake.version2 and set the file name to explosion sim bake.$f3.bgo.sc and accept that. And for the simulation cache, I channel referenced this to the Pyro Solver start frame, so you could do the same thing for the explosion bake if you want, or we could just copy the frame range from this main simulation explosion cache. So I'll just right click that start and end, copy that parameter, and paste the relative references to the other cache in the cache for our baked up explosion. So paste the relative references in there. So this will cache from 80 to 240. Let's turn on load from disk. And before we cache out this baked explosion, we can optimize this a bit further because these caches can get quite heavy. My initial cache for the explosion sim took up something close to 170 gigabytes, so I would certainly be happy to reduce that if possible. And because we've generated a new scatter volume from this pyrobake volume here, this is really controlling all of the information about the light emission in this volume here. So we don't really need temperature anymore now that we've used this temperature to generate this nicer scatter information. So if we drop a blast stop after the pyrobake volume, and in the group we select the temperature volume and display that blast, you can see that even though we no longer have this temperature available, we're still seeing the same look on our explosion here. It's not really affecting our shaded results. So after adding that extra bit of optimization, we can go ahead and cache out this baked explosion. And then we can reattach this transform that we're using to make our explosion a bit bigger and more impactful. Just wire that in after the baked out explosion there. And as usual, I will add a render null to this after the transform that we can use to set up a render object. We'll call the null render explosion, and we can't really render this directly in Redshift. This will work nicely for our Mantra or Karma renders. So we'll cache this out as it is now, and then next we'll take a look at modifying this for some nice Redshift renders.